sign of defenselessness. Nobody knows why we cry, but the theories are legion. Obviously, there is an emotional element. At other times, tears are produced as protection against dust and smoke. In 2009, an evolutionary biologist looked at it from a survival angle and asked, what evolutionary benefit does crying offer? Oren Hassan's analysis suggested that it showed defenselessness, but in a good way. Physical signs of helplessness, like crying, are not threatening signals. As such, tears could mitigate violence better than an argument. Tears also evoke sympathy in others, and any protection increases the individual's chances of survival. Additionally, people crying together may strengthen bonds. Hassan readily admitted that it might only be effective in certain situations. Obviously, bawling in front of one's boss will not provoke a sympathetic salary increase. Why happiness brings tears? Crying is mostly associated with negative emotions like grieving and sadness. However, people cry at weddings and even when they win the Olympic gold medal. As it turns out, the brain cannot tell negative and positive emotions apart when it comes to turning on the waterworks. The hypothalamus, an almond-sized region, just reacts to the overwhelming flood of emotion. It fails to detect the stress or joy behind the flood. Either one is merely a powerful signal from the amygdala, our emotional register. Once the hypothalamus receives the signal, it activates the autonomic nervous system. The gold winner and the guy who lost the race cry for different reasons, but remarkably, their brains' dominoes fall in exactly the same sequence. Why onions make you cry? Few people like chopping onions. This evil vegetable makes the eyes weep copiously, and the eyelids sometimes shut of their own accord. Why does this happen? The answer is somewhat hilarious. The onion is defending itself. The damage brought on by cutting releases a chemical designed to put off whatever animal is trying to eat it. The chemical is called propantheal S oxide. Once it escapes the onion's damaged cells, it evaporates and drifts upward. Hitting the eye, the compound dissolves in the water covering the organ and turns into sulfenic acid. This irritates the tear gland and produces the famous "my eyeballs are on fire" feeling. Luckily, the acid is not enough to cause harm. Not all onions bite back with the same ferocity. Although the reasons remain unclear, it could have something to do with how much sulfur the onion absorbed while growing in the earth. The Virgin Atlantic Survey. When Virgin Atlantic did a survey in 2011, the results were clear. People experienced heightened emotions while flying, and air travel causes more crying. Around 41% of the male volunteers admitted that they secretly cried under their blankets while on a plane. There are no serious scientific studies unraveling why zooming through the air in a metal tube brings on the waterworks, although that could explain some of it. Being confined thousands of feet up in the sky while fearful of a crash could grate on anyone's nerves. Other elements could involve missing loved ones, boredom breeding the wrong emotions, and drinking. Sometimes, flying also causes mild oxygen deprivation, and that could mess with decisions and thoughts. Throw in the difficult horrors of airport rules and traffic, and the mind is tired before the passengers even board. Virgin Atlantic could not find the cure, but they kindly included emotional difficulties as something to be aware of during their pre-flight preparation talk for passengers. Tears could generate electricity. Lysozyme is an enzyme in human tears, egg whites, saliva, and the milk of mammals. When crystallized, It exhibits the potential for piezoelectricity. This energy is produced by certain substances under pressure. One example is quartz crystal. In 2017, scientists made the first attempt to test whether lysozyme really could produce electricity. To have the potential was one thing, but it was quite another to generate an actual current. The protein was smeared over films which were subjected to mechanical force. When the readings were recorded, the results showed that the enzyme sparked power on PAR with quartz. Lysozyme has the more exciting benefit of being biological and non-toxic. This promises perks in the biomedical field, especially with implants in need of antibacterial and electroactive coatings. One day, it might even power devices inside the human body.